Okay.
Your little black boy.
All right, the regression line. You did this back in algebra and advanced algebra. You kind of eyeballed the line in there and use it to predict. But there is a nice mathematical, statistical way to find the best regression line. It's not an eyeball thing. So, and what it uses it's called the sum of the least squares. But what you've got is your scatter plot. And you were taught to draw that best fit line in there, what you thought was the best fit line. So I'm just going to eyeball one in here. And the goal is to get the line so that when I take the vertical distance, like say I look at this one point here, if I look at its vertical distance from my trend line, we'll call it a y. We do that for all the points. We find the distances away, and you want to minimize that total distance. That's your goal. Get the slope in there that makes, in the y-intercept that makes those total distances a minimum. And that vertical distance is called a residual. It's the vertical distance from the observed point and the regression line. And the goal, like I said, is to minimize that total distance. So, it's just, we're doing linear functions, so the equation of a line, we're going to call it y hat because it's made from sample points, mx plus b, where you need to know the slope and the y-intercept. Those are the two things you got to figure out. Well, the statisticians found a way to get the slope and y-intercept to make that best fit line with those residuals being a minimum. To calculate the slope, you're going to take the number of data points, multiply by the sum of each x and y multiplied together, subtract the sum of the x's multiplied by the sum of the y's over, it's a lot with the lists and things like we did on Friday. Oh, well, good thing we're doing it again today. The sum of the x values squared minus the sum of the x's squared. That'll get you your slope for your regression line. And to calculate your y-intercept, you're going to take the sum of the y's, divide by how many? Minus that m value you calculated here, multiplied by the sum of the x's, divided by your number of data points. And if you think about this right here real quick, if you add up all the y values and divide by how many you have, what are you actually finding? When you add up a data set and divide by how many you have. It's an average. It's the average of the y's. You could call that y bar. And same thing here. The sum of the x's divided by how many you have. It's just the average of the x's. So instead of calculating the sum and dividing by how many, we can just grab the off of one bar stats each little average. Okay, we're going to practice one of these. And we're going to use that same data set that we had on Friday. You probably have to put it back in again, but it's only 6 data points. So, example 1 is to find the equation for the regression line. Find equation for the regression line for salary and donating percent. From 9.1. And if you look at these formulas, you're going to tell me how many lists we need to do, because you're good. You're going to be understanding what all that symbolism actually means. So let me get mine should still be in here, hopefully. Yeah, I'm going to get rid of my list 3 though, and my list 4. Okay, so the data points are there. 42,000, 9% donating, 48,000, 10% donating. So go ahead and fill those in. So you've got the points. And I'll wait for you. Yep, those are the numbers you're using from.
What's the number under 65?
Under 65 is 72.
We have to like write them down.
No, you don't have to write them down.
Oh, then maybe.
You're going to put them in the calculator. We're actually just going to do it. Because we already have them written down in 9.1. But you weren't. Are you there?
Oh, I missed the 9 one part. I got it now.
Okay. This was the X values, remember, represented the amount of money in thousands of dollars, their annual salary. And then the second part was what percent of their salary they donate to charity.
Then 856.
8563.
Okay.
And now we're gonna do the multiply by 2.
Okay, yep, if we look at the very first thing I need to add up the product of the X times Y. Do we have the X times Y multiplied out yet? No. So let's go over to list 3. And we'll say take L1 and multiply it by L2. Okay, I want the sum of those products now. How do I get the sum again? Let's go to 1-bar stats. We're going to run 1-bar stats on list 3 to get this number. So we're going to quit. 1-bar stats on list 3. And what number do we want out of all that mumbo jumbo that came up? The X, sum of the X. So 2,159. And what's our N? We had 6 data points. I can answer that. We just got a sum of 2,159. I need the sum of the X's next. Where are our X's at?
L1.
L1. So we're going to run 1-bar stats on L1, and we're going to get this number, and this number off of it. So we want all 3 of those filled in. So stat, calc, 1-bar stats on L1. So the sum of the X's, 336. We'll fill in the sum of the Y's. I'm going to the bottom here, 6. Because we can get the sum of the X squared off of this screen also. See it on the 3rd line down, the sum of the X squared?
Yeah.
19,458. And then minus that sum of the X, that's the 336, I've got to square that number. And then the only other thing we need are the sum of the Y's. Well, actually, I'm going to write down the average of the X's while I've got it, because I'm going to need it down here. So can I write down that average right now? X bar off to the side. Average is 56, because I know I'm going to need it down there.
Why'd you write down 336? Oh.
Because our formula says, find the sum of the X's, get that number, and then square it.
And that third thing, what's the third thing?
Third thing is square all of the X numbers first,
And
then add them together.
Okay.
So they're slightly different. Okay, we need the sum of the Y's and the Y bar. So we need 2 things from that list 2. So stat, calc, 1-bar stats, L2. The sum of the Y's is 41. And the y bar is the x bar here, 6.83. That's all one big calculator line. Where do we need parentheses at? Yep, the numerator needs a set of parentheses. And the denominator, that should be it for parentheses. No other parentheses needed. So this will give you the slope of your regression line. It better come out negative because we had a negative relationship. Sounds good. Now we need to find the b value for our regression line. The b is the average of the y's, which I wrote down off to the side here, minus that m value you just found, multiplied by the average of the x's. Zoe, what'd you get?
18.76.
And now you're ready to write the equation for your regression line. Our slope was negative 0.213 times x, and then plus the y-intercept of 18.76. And then they'll ask you to use that equation to make some predictions. So if somebody made $58,000, what would you expect them to donate? You need to stick 58 in there, just like Algebra 1 stuff. Okay, your assignment page.
You got a
that's it?
question?
Yep. Yes, what's your question?
I didn't get 18.76.
What'd you get?
I got 300.
You are wrong. Try that again. Did you do minus the negative 0.21? This is right. Try it again. 6.83 minus, try it again. 6 through 10, 12, 14, and 16.